my screen here?
Yes.
Okay. So what we have here, we have a particle of mass 0.4 kilogram projected speed 12 meter per second, upline agreed the slope of the smooth plane 30 of the horizontal. Okay, now about the initial kinetic energy. Kinetic energy here, all unit here is half mv square. So all you need to do here is this and this. So it's going to be half times 0.4 times 12 square. There is no need about the directions. Okay, so we don't care about the direction here. This is all unit. So this is going to be 0.2 times 144. That's going to be 28.8. Okay. Don't forget to put the joule after it. That's it. Okay. Okay, clear enough?
Okay.
Okay.
Which paper is this? Sorry.
Okay.
Which paper? Let me check. Okay.
Oh, here. Okay. Use energy method to find the distance particle moves up the plane before coming to instantaneous rest. Okay, energy method means we are going to use this equation. Okay. Energy kinetic position 1 plus energy potential position 1 plus energy input equals energy kinetic position 2, energy potential position 2 plus energy going out. This is what we mean with the energy method. Now, in this case here, we already know the value of the kinetic energy for the first position. This is going to be energy kinetic 1 is 28.8. We know them here. Okay. Before instantaneous rest here means energy kinetic position 2 is going to be 0 because okay, V at position 2 is going to be 0. And then in this case, energy potential 1 is going to be 0 because we have them, that's the lowest position because the position number 1 is 0. And there is no information about any force or any friction. So here energy input is 0 and energy output is also 0. Okay, now we can put them all in 28.8. Okay, it's going to be plus 0 is 0 plus EP2 plus 0. So it's easy to see now. We know that energy potential at position 2 is 0. Okay. Up until this, any question?
Wait, EP2 is 28.8, right?
Yes, 28.8. Yes. It's the previous answer.
Okay.
Any question from the address? Caroline, Patricia, Jane? No?
Itu energy potentialnya
Mm-hmm.
0 atau
Yes.
28.8?
Energy potential, which one? Number 1 is 0. Number 2 is what we find out.
2.
Energy potential 2 is the one that we want to find out, EP2. So this one is EP2, the one that we want to find out here.
Yang we have to find out in like II, right?
Yes. Mm-hmm.
Berarti itu 28.8.
Yes. So here EP2 is 28.8. Right?
Okay.
Okay, now let's see here. If we see, if we make some sketch here, this is the angle theta. That's going to be 30 degrees. 28.8 is the vertical distance, 28.8. They are not asking this, they are asking the distance here, the distance of the move. Okay. Now I'm going to write here, yeah. From the definition of sine, we have 28.8 over distance 8 is the sine of 30 degrees. I repeat, the definition of the sine is opposite over hypotenuse. This is the opposite, this is the hypotenuse. So 28.8 divided by S is cos 30, or S is 28.8 divided by cos 30 degree. Use your calculator, you will get 57.6. Sorry, 57, yeah,
Okay.
7.6
Oh,
meter.
it's like because it's sine, right? Like the sine.
Yes, sine. Yeah, sine, sorry, not cos, my bad.
Itu cari apa sir yang itu? Cari distance.
Iya, cari distance-nya.
Jadi cari distance itu
Ini dibagi ini kan namanya cos. Sorry, sinus, sorry, sin ya. Jadi kita pindah tempat. Ini sama ini pindah tempat.
oh bentar sir. Jadi kita cari hypotenuse-nya.
Hypotenuse yang mau dicari. Kan?
Oke.
Terus kita pakai definisi dari sine. Sine itu adalah opposite per hypotenuse. Hypotenuse-nya nih, distance-nya yang mau dicari. Nah, kalau kita tukar tempat, berarti 28,8 dibagi sin 30, itu adalah si S-nya, 57,6 meter. Oke, gampang ya. Oke, can we go to the next question? Yes.
Jadi distance itu selalu cari hypotenuse-nya.
Iya, di sketch aja dulu. Seperti ini. Ini kan kita lagi naik nih. Jarak ke sini namanya S-nya, di distance-nya. Kan? Tapi yang kita ketahui bukan jaraknya, tapi tingginya. Karena energi potensial itu adalah M times G times H.
Iya.
Oke.
Oke.
Oh, sorry. I forgot something. My bad. The H, not 28.8 here. Okay, I almost forgot. Sorry, I'm taking. Okay. Tadi sampai ya. Energy potential itu is 28.8 ya. Okay. Nah, tadi kita gambar. Ini adalah 28.8 ininya. Ini adalah S-nya. Ini adalah 28.8. S itu adalah. Sorry, my bad. Hampir lupa. Is M, G, H is 28.8. So H is 28.8 divided by mass 0.4 and the gravity. For mathematics, we use gravity of 10. Yeah, my bad. I forgot to put the H and G here. 28 divided by 4. So that's going to be 7.2. 7.2 meter. Sorry ya, tadi Pak, I take back there. The H is 7.2. And then from the H, we use the S here. The distance is 7.2 over the sine of 30. So it's 14.4 meter. Ya, sorry, tadi Pak lupa belum dibagi dengan mass dan gravity. Ya. Oke, am I clear enough for here? Cukup jelas?
Yes.
Yeah.
Ya, next ya. Nanti kalau kurang jelas bisa dilihat lagi ininya, videonya ya. Oke, oh ini klasik ini. A particle P mass 1.6 suspended in equilibrium way by two inextricable lights, bla bla bla. 40 find the tension and two rings. Nah, kalau seperti ini, kuncinya adalah we are going to break them into their component. Yeah. Let's say the tension of A here is going this way, and this is the tension of B. Okay. So seeing from point of view of A is being pulled that way. Okay, this is the TA on the x-axis. That's going to be TA times cos 20 degree. Can you see it?
Yeah,
Hello?
the TA times 20 cos 20. Try to.
No. Can you see my scribbling?
No.
No. Okay. Wait. Wait. So here we are. We know this is going to be 20 degree,
I haven't
40
shared the
degree.
screen.
Oh, sorry. Forget to share the screen. Can you see it now?
Yep, finally.
This is point A, this is point B, and this is point P. What we know is there is a B here. So P will have the weight of P. The weight of P is going to be mass of P times the gravity. So it's going to be 1.6 kilogram times 10. Okay, so it's going to be 16 Newton. So WP is going to be 16. Okay, now the tension in B, if we see from P, we can break it down into the vertical part. This is tension B on the y-axis, and the horizontal part, this is tension B on the x-axis. Okay. Tension of A is going to pull it this way. Okay. And we are going to break this into tension A on y-axis and tension A on the x-axis. Okay. Now let's break them down. Tension A on the x-axis is going to be tension A times cos 20 degree, which is, okay, anybody get calculator? What is cos 20? Hello?
0.9396.
Very good. 0.9397 of TA. Okay. Tension B on the x-axis is going to be tension B times cos 40 degree. Okay. What is cos 40 degree? It's going to be 0.7660 tension B. Okay, next, tension A on the y-axis is tension A times sin of 20 degree. So it's going to be 0.3420 tension A. And tension B on the y-axis is tension B times times sin of 40 degree. So it's going to be 0.6428 tension B. Okay, up until this, any question?
No questions.
Okay. Now I'm going to rewrite again using only the part that goes in B, and the P here. This is going to be 0.TA, this is TAX, 0.9397 TA, is going to be 0.7660 TB. This is going to be TBX. This is going to be TB on the y-axis. That's going to be 0.6428 TB. And for the TA, it's going to be 0.3420 TA. Going down, we have 16. Okay. So this is of everything that goes in point B, this point B. Now, their equilibrium, so the total of left and right is 0. Total of up and down is 0. Okay, means 0.9397 TA equals 0.7660 TB. We can use this to calculate TB in terms of TA. So TB 0.9397 over 0.766 TA equals to TB. Okay. So 1.2267 2268 TA is TB. Okay. Up until this, any question?
This is for the x-axis, right?
Yes. For the x-axis, in x-axis left equal right. So we now have TB in terms of TA. Okay, so here I'm going to sketch them. 0.9397 TA equals 0.7660 TB. So we now here TB in terms of TA. Now let's do the vertical. In the vertical, we have three forces, two up and two down. The up, two up and one down, sorry. The up says, what is it? The up 3420 TA. And also 6428 TB. And down is 16. Okay. Now we're going to change this first. 0.6428 TB is 0.6428 times 1.2268 TA. We're going to make them in terms of TA. So it's going to be 0.7886 TA. Okay.
So that means 0.6428 TB is equals to 0.6428 times 1.268 TA.
Yes. The TB here, we are going to change this with TA. Now we're talking about TA only. Okay. Okay. Now imagine now I'm going to make the new graph here, but now it says 0.3420 TA and the other 0.7886 TA, and down is 16. We are changing the TB here into in terms of TA now. Okay, now the up, total up equal down, right? 0.3420 TA plus 0.7886 TA equals 16. If we total this plus 0.3420, we have 1.1306 TA is 16. So TA is 16 over 1.1306. So it's going to be 14.1. Okay, let's pause this. Up until this, any question? Caroline?
Tension A, that means tension A is for the every single tension, right? Like the tension in general, so it's 14.15 newtons.
Yes.
Okay. That means tension
now,
just replace.
Multiply it by 1.2, yes. But we know what TB is. TB is 1.2268 TA. 1.2268 TA. So TB is 1.2268 times 14.15 Newton. So it's going to be 17.36 Newton. Okay, this is this and this one. Okay, now this is the principle of having equilibrium questions. You almost have them, almost always have them in all cases. Okay, I'm going to repeat, yeah. First, if you have the answer here, okay, you are going to change everything into numbers in axis, x and y. Okay. So if you have the number here, change them into x and y axis. For x, that's going to be cos. For y, it's going to be sine. Now, I suggest you to sketch graph like this. Sketch graph like this is going to help us visualize what was meant. Equilibrium means we know left equals right and up equals down. In this case, let's take the left and right because it's going to simplify things. Once we see this here, we can find TB in terms of TA. So here, we're going to have this one here, TB in terms of TA. This is going to be very useful as we go into the vertical axis. Now, I'm sketching here the vertical axis. Previously, we have the information in terms of TB and TA. Now, the TB part, we change them into TA. Using the equivalence, TB is 1.266 TA. If we do that, now our data is just in terms of TA. So this is going to simplify. Okay. Now this is simplify. So the simplification now read that we have two force here. The up is 1.1306 TA and down is 16. We put them together. Okay. Now with this, it is we can find the TA then. TA is just 16 over 1.1306. And we can find out what is TA. How about TB? Well, we already know how to find TA from TB, right? That's it. TB, put the value, we have them here. 12268 times TA. We know TA now, we can calculate TB. Okay. Is it clear enough here?
Itu sir,
Yes.
the number itu
Yes.
selalu
Yang
harus
nama?
kayak yang itu, yang pokoknya yang bukan degree.
Yes.
The tension itu always harus kayak 4 decimal itu.
Oh, enggak sih. Biasanya usually they want for 3 decimal point unless otherwise stated. But usually I use 4 decimal place for clarity. Usually the answer
Okay.
is just asking for 3 decimal point. Check the question. If they don't have them here, the default is 3. But I'm calculating in 4 to increase the accuracy.
Oh, okay. Thank you, sir.
Welcome. Okay, next question, yeah.
Final question
Yeah.
before you have to go, right, sir?
Sorry?
You have to go on at like in a couple of minutes, right?
In 5 minutes, yes. Okay. I think we have time for a little bit more here. Okay, let's have this question here.
Can't see the question. You have to not share it and reshare the screen again because you're.
Oh, okay.
Except if you have the paper on the paper.
Yes. There, okay. So here, a car mass 900 kilogram moving on straight line, horizontal ABCD. There is a constant resistance to motion, 800 Newton in sections AB and BC, and constant magnetism R in section CD. The power is 36 kilogram. The car moves from A to B constant 120. Find the speed of the car and the distance AB. Okay. Okay, now let's sketch this. We know here there is a constant resistance. Okay, this is from A to B, yeah, from A to B. There is a resistance, and the resistance we know it is 800 Newton. Okay. Now the car is going to push it forward with the magnitude of F. Okay. In this case, they say they have a constant speed. Constant speed means acceleration. We write them here. Okay. Constant speed means acceleration is 0, means sum of the forces is 0. So F equals 800. Okay. Okay, up until this. Okay, yeah. Now, once we get the force, what is the speed? The power is force times velocity. Hence, velocity is power over force. 36,000 divided by the 800. So that's going to be 45 meter per second. Okay, up until this, any question? I repeat, yeah.
The power is like power is force times velocity, right? We got the velocity
Yes.
from the force because it's like it's constant speed.
Constant, yes. The P is always constant. We know the power, we know the force, so we can find the velocity.
That means if there's a word like constant speed, that means we have to say that it's like it's general knowledge that
yes,
within a zero. That means
you're going to get them here. That's the importance of constant speed. If it's constant speed, you have no acceleration. No accelerations means no force. Okay. And the distance is velocity times time. So it's 45 times 120. Okay, what's that? 5,400 meter. Ta-da! Okay, it's a short 3 marks, right? Okay.
So
For 3 marks, this one, yes?
I have a question. For example, like the previous question, I forgot the previous question. It's like mass gravity, right? So I recall from like previous questions, like 1.6 times 10 velocity times.
Yes.
For example, but then the question is in kilogram. For example, if the mass is in gram, should we convert to kilogram first?
Yes, change them for kilogram first.
Okay, thank you.
Okay, I think that's it for now. I need to go see my dentist for